This is a video about the special right triangles that have two 45-degree angles and one 90-degree angle, and then also one 30-degree angle, one 60-degree angle, and one 90-degree angle. So we'll be talking about those within the context of the unit circle and then generalizing our results. Alright, so I've drawn in a 45, 45, 90 triangle, my unit circle. So this triangle is going to be isosceles because it has two 45-degree angles. I know that there are two 45-degree angles because a triangle has 180 degrees, theta is 45 degrees, I have a 90-degree angle right here, so then I need another 45 degrees to total up to 180. So this is an isosceles triangle, which means that my x and my y are equal. And then I know that my hypotenuse is 1 because this is the unit circle, and the radius equals 1 for the unit circle. The equation of my unit circle is x squared plus y squared equals 1. So now, with these two equations, I have two variables, so I can create a system to solve for my variables. So I'm just going to substitute my x in for y, so that I get x squared plus x squared equals 1. And I'm going to solve for x. And then in my last step, I get that x equals the square root of 2 over 2 after I rationalize my denominator. And I had to start with that x equals y, so that means my y also equals root 2 over 2. So I've just been talking about this as a triangle. However, we're interested in our trig functions. We defined our cosine theta to be the x-coordinate of the point determined by the terminal side of theta. So in this case it's 45 degrees. So that means that cosine of 45 degrees then equals root 2 over 2. And then we defined our sine of theta to be this y-coordinate, so sine of 45 degrees is also root 2 over 2. So that's the coordinates of this point right here. Root 2 over 2, comma, root 2 over 2. Now that we have the values of our sine and our cosine of 45 degrees, we know the tangent, because the tangent is just sine over cosine. And in this case, our sine of 45 degrees is the same as our cosine of 45 degrees, and a thing divided by itself is just 1. So the tangent of 45 degrees is 1. Now, since our trig functions here are ratios, it didn't really matter that our radius was 1, necessarily, that we got that our cosine of 45 was root 2 over 2. So no matter how big your triangle is, you're going to get that your cosine of 45 degrees is root 2 over 2. The sine of 45 degrees is always going to be root 2 over 2, and the tangent of 45 degrees is always going to be 1. Now I want to take a moment and talk about the symmetry of the unit circle. So we've got this point with positive coordinates, root 2 over 2, for both x and y. So over here, we can determine another point that has the same coordinates except with a different sign. So I'm just going to move left, go on my negative x-axis, negative root 2 over 2, and then go up root 2 over 2. So this angle right here, the reference angle for this point is 45 degrees. So this is also a 45, 45, 90 triangle. I also have one in the third quadrant. Sorry, my circle's just not scaled to my axes. And this one will have negative coordinates. And then I've got one in the fourth quadrant that's got a positive x coordinate and a negative y coordinate. And this also happens to be a reference angle of 45 degrees. So anytime your reference angle is 45 degrees, your sine and cosine are going to have an absolute value of root 2 over 2. And then your tangent is going to be either positive or negative 1. So that just, the sign of your coordinates is determined by your quadrant. So in quadrant 1, both your x and y's have a positive parity, so that means that your tangent is also going to be positive. So all of our trig functions here are positive in the first quadrant. In the second quadrant, our x's are going to be negative, but our y's are going to be positive. So that means our cosines are going to be negative, but our sines are going to be positive. So then when we talk about our tangent, which is the ratio of the two, if one is positive and one is negative, we have that a negative divided by a positive is a negative. So our tangent is going to be negative in the second quadrant. The only thing that's going to be positive is sine. In the third quadrant, both our x and our y are negative, so that means our cosine and our sine are negative. So that means the ratio of the two is going to be positive. So in the third quadrant, our tangent is positive and sine and cosine are both negative. So when we move to the fourth quadrant, we see that our x's are positive but our y's are negative. So that means that our cosines is positive in this quadrant, and then everything else is negative. So the way I remember this, A is for all, S is for students, T is for take, C is for calculus. If you remember, all students take calculus, going in order by quadrant. So that's quadrant 1, 2, 3, and 4. That'll tell you which trig function is positive. Alright, so we can use a similar kind of thinking to talk about our 30, 60, 90 triangles. So the first thing I'm going to do is draw in a 30, 60, 90 triangle, and then I'm going to draw in another one right here, just like so. So this angle is 30 degrees, or I guess technically it's negative 30 degrees in our unit circle, but if we're talking about just a normal triangle without the context necessarily, it would be positive 30 degrees. So that means we have 3 60-degree angles for our overall big triangle. So if we've got 60, 60, 60, then that means this triangle here is equilateral. We know that this distance is 1 and this distance is 1 because it's the unit circle. So that means that this other side altogether has to be 1. So that means the height of each triangle is going to be 1/2. So that means that the y-coordinate for the top one is 1/2, and then the y-coordinate for the bottom one is negative 1/2. So now we need to determine what the x-coordinate is. So both of these points are going to have the same x-coordinate because they are vertical from one another. So we can use the Pythagorean theorem because we know two sides of our triangle, just like so. we just solve for x, and we get the x equals root 3 over 2. So we can just write that in, root 3 over 2, root 3 over 2. If we look at our signs for our coordinates here, we see that it is indeed our cosine that is positive, because our cosine of theta, so our cosine of 30 degrees, is root 3 over 2. So that means that our reference angle, right here, is 30 degrees. So our cosine was the same as for the 30-degree angle. This is the same phenomena we just experienced with tangent, or with our 45, 45, 90 triangles. So once again, we also have a reference angle of 30 degrees over here, and a reference angle of 30 degrees over here. These are the coordinates. So anytime your reference angle is 30 degrees, the absolute value of your cosine is going to be root 3 over 2, so it'll just depend on which quadrant your angle is in. And then your sine of 30 degrees is going to be either positive or negative 1/2, depending on which quadrant you're in. So this is why your reference angles are really, really useful. So in summary, we've got that our cosine of 45 degrees is root 2 over 2, our sine of 45 degrees is root 2 over 2, and then our tangent of 45 degrees is 1. We've just discovered that our cosine of 30 degrees is root 3 over 2, and that our sine of 30 degrees is 1/2. Now we can determine our tangent of 30 degrees, because it's just sine of 30 over cosine of 30. So we have 1/2 over the root 3 over 2. We get root 3 over 3. Sorry, I thought I paused recording there for a second. Now, by nearly identical logic, we can do the same thing for 60 degrees by kind of changing the orientation of our 30, 60, 90 triangle. So I can just extend this out this way, just like so. And then I would end up finding that this distance here, all I've done is reorient my triangle. So it's the same triangle, my hypotenuse is still 1. I've just kind of changed the order of my base and my height. So that means my x distance here now is going to be 1/2. And then it's my vertical distance, y, that is root 3 over 2. And then here it'll be negative root 3 over 2. Just like so. So here, all of these points form a reference angle of 60 degrees. The absolute value of the x-coordinate for all of them is 1/2. The absolute value of the y-coordinate is root 3 over 2. So we have that from our first quadrant angle, that cosine of 60, that's our x-coordinate, equals 1/2, and that sine of 60 equals root 3 over 2. Then to find the tangent, we simply need the ratio. So we have sine over cosine, and that simplifies to root 3. So this is a summary of the values that we've just gone through. Now remember, if your reference angle is 30 degrees, then you're going to use these values here in the 30-degree column. Your sine is dependent on which quadrant your angle is in. So I just always think all students take calculus, and that tells me what's positive. I drew them like this because that would be my quadrants, right? So in quadrant 1, all three are positive. In quadrant 2, only the sine is positive. In quadrant 3, only the tangent is positive. And then in quadrant 4, only the cosine is positive.